And today we are going to start a new unit, and this unit also carries 8 marks, and it is very important unit. Okay, only 2 chapters are there in this unit, but it is very important for your higher secondary level also, and also for your that means for degree and everything. That means entrance. For entrance, if you go to the entrance, you have to learn this chapter properly, and you have to go through all the topics. Especially the 2 chapters consist of one is known as total name of the unit is current electricity, but the name of the chapters are electrical measurements, and another one is what electrical circuits. Okay, there are 2 units which there are 2 chapters which are very important, and name of the unit is what? Current electricity. At last unit we have learned everything about how the charges are giving force, how the charges are giving lines of force, how the charges are attracting another charges, how the charges are giving stored, how the charges are giving potential. Everything we have learned. That means we have learned where the charge is at rest. We have learned everything where we have considered the charge is at rest. Okay. And now the practical application. Practically, if you go through the practical application of the charges, you will see that without motion of the charge, nothing is possible in this world. Is it clear? Without motion, that means when the charge moves from one point to another point, motion of the charge moves one point to another point, and there is a creation of what? Electricity. Is it clear? When there is a motion of the charge, there is a creation of electricity. Is it clear? And the branch of physics which deals with the motion of the charge, the branch of physics which deals with the relation about the motion of the charges is known as current electricity. And you know, without current electricity, nothing is possible in this universe. Is it clear? If you go through, if you are thinking about, when thinking about the fan, if you're thinking about the light, if you're thinking about the TV, everything runs on the electricity. So the main applications of this, the motion of the charge, is everywhere. Is it clear? Everywhere where we are present, everywhere we can see about the application of the charge. Okay, and application of the motion of the charge, especially it is current electricity. Now, what are the carriers of the charges? How are the carriers of the charges? Generally in solids, in metallic conductors, that is in metal like aluminium, copper, silver, the valence electrons are the charge carriers, because these charges, these valence electrons are not attached to a particular parent ion. So they are free electron and they can constitute electric current. When they move from one point to another point, they can constitute electric current. Again I am saying, in metallic conductors like your copper, silver, aluminium, what is that one? In metallic conductor like our copper, silver, aluminium, the valence electrons are charge carriers. Is it clear? And these electrons generally not attached to particular ion and are known as what? Particular ion, particular parent ion. So they are known as what? Free electrons. And so when we give electric field, they can move from one point to another point, and they constitute electric current. In semiconductor like silicon and germanium, the process is similar to that in metal, but here the number of charges is very small. Is it clear? These charges Carriers can be negative, that is electron, or positive, known as holes. So in case of semiconductors, we can say that there are two types of charge carriers are there. One is known as electron, known as negative charge, and other one is known as hole. Is it clear? Now you are not getting my point, because why? We are not dealing with the electronics chapter. When we deal with the electronics, we will get more. We will learn more things about this chapter. Now it is the chapter of electricity, so we should think about the electricity. Is it clear? Now, what will happen in case of liquids? Whether there is any motion, whether there is current flowing in some liquids, allow electric current to to pass through them, and consequently dissociate into ions called electrolytes. That means what? The solution which allow the electric current to pass through them are known as electrolytes. Is it clear? And the examples of electrolytes are copper sulfate solution, AgNO3 solution, NaCl solution, H2SO4 solution. In this solution, you will see that copper 2 minus, SO4 2 minus, Ag plus, NO3 minus, Cl minus, NO3 plus, sorry, Na plus, positive ions are called cation. There are some positive ions are known, they are known as cation. And the negative ions are known as what? Anions. Is it clear? Under the influence of high electric field, these ions will move from one point to another. Both ions and cations will start to move on the liquid surfaces and constitute electric currents. Is it clear? Now, in case of gases, generally gases are insulated. They have not property of the electricity. But at high pressure, at low pressure and at high potential difference, they may give what? Electric current. And they get ionized and becomes conductor. What happens in case of gases? Generally gases are insulated. But when the pressure is very low and potential difference between 2 points is very high, then these gases will become what? These gases will ionized, and these ionized gases will give us the electric current. So from there we can say that we can get current in the solids, we can get current in the liquids, and it can get also current in the gases also. In solids, where we can get, where the free electrons are there, like copper, aluminum, silver, okay. And in solid there are another types of material is known as what? Semiconductor, and the main carriers of current in the semiconductors are holes and what? HOLES, holes, not don't write WHOLE, holes and negative charges, okay. And in case of liquids, some electrolyte solutions are there. All the liquids will not allow to flow the current, but some electrolyte solutions are there. Suppose copper sulfate solution, H2SO4 solution, NaCl solution, and another one is AgNO3 solution will give what? Will allow the flow of electric current, because when these electrolytes they are known as electrolytes, and they carry charges known as cations and anions. And when electricity is allowed to pass, when you give some electric field, then what will happen? These ions and cations will move from one point to another point, and they will give you the value of electric current. In gases, what we come to know, in gases generally there is no flow of current is there. It is because it is an insulator. However, at very low pressure and at a very high temperature, these gases attains the property of what? Conductor. How? Because it becomes the gases ionized, and these ionized gases will give what? Electricity. So from there we can see how the current is forming in everywhere, in solids, in liquids and gases, isn't it? Now, what is electric current? Generally, what do you know about the electric current? The rate of flow of electric charges is known as electric current. Generally, the flow of charges per unit time is also known as what? Electric current. The rate of flow of charges is known as electric current. This is the basic difference this is the basic definition we have learned in the class 6 or 7, I don't know, 6, 7, 8 we have learned. What is current? The rate of change, the rate of flow of what? Charge is known as electric current. Mathematically it is I equal to dq by dt or q by t. What is q? Q is the charge and t is the time. Now what are the units of electric current? SI unit of electric current is ampere. And electrostatic unit of electric current is stat ampere. Electromotive unit of electric current is AB ampere. How can you define SI unit of electric current? If a charge of 1 coulomb is flows through a conductor in 1 second. If a charge of 1 coulomb flows through a conductor in 1 second, then you can say it is what? It is 1 ampere. Again, if a charge of 1 stat coulomb passes through a conductor in 1 second, then you can say it is 1 stat ampere. If a charge of 1 AB coulomb passes through a conductor in 1 second, then you can term it as a what? We can term it as an AB ampere. So there are 3 units we come to know. One is known as what? Ampere. Next one is what? Stat ampere. Third one is what? AB ampere. Now we are going to discuss about the dimension. Dimension is what? M0, L0, T0, A1. Is it clear? So what is that? What are the dimensions? 0, 0, 0, 1 with respect to mass, length, time and electric current. Is it clear? Now we are going to discuss the relation between ampere and stat ampere, then relation between ampere and AB ampere, and the relation between ampere, stat ampere and AB ampere. First we go through the ampere and stat ampere. We know 1 ampere equal to 1 coulomb by 1 second, and 1 coulomb is equal to 3 into 10 to the power 9 stat coulomb divided by 1 second. So the result will be 1 ampere is equal to 3 into 10 to the power 9 stat ampere. Is it clear? Again, a relation between ampere and AB ampere. We know 1 ampere equal to 1 coulomb by 1 second. So 1 coulomb again equal to 1 by 10 AB coulomb. So the result will be 1 by 10 AB ampere. And now when we are going to find out the relation between stat ampere and AB ampere, we'll go through like this. We have 1 ampere equal to how much? 3 into 10 to the power 9 stat ampere. Is it clear? We know 1 ampere equal to 3 into 10 to the power 9 stat ampere. And 1 ampere equal to 1 by 10 AB ampere. So 1 by 10 AB ampere equal to 3 into 10 to the power 9 stat ampere. So the result will be 1 AB ampere equal to 3 to 10 to the power 10 stat ampere. So this is about the relations between ampere, stat ampere, ampere and AB ampere, stat ampere and AB ampere. So please go through this video regularly. Okay. We will give notes recently. Those who are regularly watching the video, make your notes from that video also. Okay. I will check when you are coming to the regular classes. When you come to the regular class, I will check your notes. Okay. Your copy I will check. Please go through it.